Okay.
Do you still see the presentation, right?
Yeah.
Okay.
I'm seeing your presentation. It's already recording.
Yes, possibly.
No.
I'm not sure if it is recording previous part when we were in the green room. Anyway, oh, yeah. We are having people being connected already. Hello?
Hello? Where do you see people connecting? Oh, here. Right.
Fábio, I think we can already start.
Okay. Let's go. Hello, everyone. My name is Fábio Peruchi. I'm from Brazil. I used to work in the past as a software architect, working with Java and .NET, but from 7 years to now, I'm working as a DevOps specialist, and I'm working here in Pathable for 1 year since then. And that's it. Now pass to you, Nacho, again.
Thank you, Fábio. Hello, everyone. This is Nacho Codoñer. I am origin from Valencia, Spain. I am a JavaScript developer that has been working with the Meteor stack for many years and also using React. But at some point, maybe 3 years ago or something like that, I was really self-interested into everything related with automation and productivity on using tools and etc. That is why the logical evolution has been now to work into DevOps domain. And here in Pathable, we are having now the opportunity to focus in this area to research and apply this knowledge practically in a production environment. First, I'm going to introduce Pathable for those that don't know about it, but I think you know about them or you are using it actually. Because Pathable is a platform to organize and to produce a desktop and mobile application for in-person, hybrid, and virtual events like the one that you are attending already. Meteor Impact is powered by Pathable. We provide to event hosts a bunch of features to customize their event experience. At the end, Pathable is like a CMS for events. We are continuously providing features to the platform and trying to improve the quality on it and the experiences for the event hosters and attendees. We are one of the main Galaxy customers. According to the development team, we are approximately 25 developers that are spread out of the world, and we are working 100% remotely. So now let's take the hands into the presentation itself. The presentation is going to be to talk about the development process we settle in Pathable. But before talking about that, let's ask ourselves why we need this process. The motivation is clear. We want to release features as frequent as possible, but at the same time, we want that these releases go to production with the less impact of bugs. As the project and the team grows, it also does the features. And as more features are working, but several people in parallel, we will reach a point that when we need to integrate the changes for everyone, we face what is known as an integration hub. To overcome this problem, the solutions reside to establish some conventions and procedures on how we manage the tasks and code changes. At the same time, we need to provide manual testing of every change that is going to production, but at the same time, for getting the most benefit of it, we need to automate it. If we automate all the integration processes and the verification procedures, we will get a point where we can release stable and quality releases. And also, any automation that we can contribute will also help to the other people's work, other developers. So it will affect their happiness. It's something that is important to pursue. The first convention that we need to have is to have a high-level work repository where all our tasks are described, planned, estimated, and assigned. This is the kind of repository that everyone has access to it, all workers of the business. We are using in our case target process And we have selected target process, but there are many other tooling because it provides some advanced customization on how we describe our tasks, the statuses, how we display them, and how we integrate it in our Agile workflow. Also, it has some integration with other of our tools we use, like Zendesk for the support people and GitHub for developers. The second convention is to have a code repository where our code lives, right? This is our way to keep all the changes that we have in our app versioned that can be in any moment rolled back. We can check out and we can have stable versions of our code. Something that I want to say more about this code management is that we are adopting the monorepo strategy. So we are keeping centralized all kind of logic and code of our company domain, which is all the apps, side packages, scripts for the environment, for the automation, everything. We are trying to go into this because the benefits are going to be that in this pipeline for integration, if you can ensure that reviews are going to be faster because everything is centralized, then you will gain velocity on your delivery. Once that I have introduced the two main parts that we have in our integration, we need to integrate these tools as well. And this is what we do with the TP capabilities that it has. So we have adopted a convention that we are tagging using the task ID, each task, which each commit in our code repository and PR. We will get for free that every time that we tag a commit, it will be available to be accessed in the task definition for everyone to check which code is affecting that task and vice versa. But for integrate and to maintain stable versions, you have also to describe a branching model within the Git context. We have adopted the Git Flow conventions. For those that don't know about what the Git convention is about, I'm going to explain a little bit. Basically, we have two main branches, baselines, where all our changes are in a stable version. We have master that is close to the last version of production, and we have development that ideally contains a stable version of all the next features that are coming in the application. When we want to provide any change, depending on the nature of change, we will branch out from a different main branch. If we want to provide a patch directly to production, we will create a hotfix, and at some point when it's validated, we will merge it and do the deploy to production. When we want to provide a minor or major version of our app, providing more features, we will branch out from features, we will validate those features and merge it to development. At some point, when we have a lot of features in development, we will branch out and create a release branch. There, we will validate all these changes integrated, and at some point, we will merge them and deploy it to production. Something interesting that I want to say here is that we have provided automation in this Git Flow strategy. So we are always trying to spread the changes from main branches to the rest of the branches. This is one of the principles of continuous integration, so that all the branches should have, as soon as possible, the last stable contents there to avoid the integration or merging hell. Then let's take a look into the development lifecycle of a new feature, how it works in Pathable. I have introduced where we are describing the high-level work, where we are describing the low-level task, which is the code. And now I'm going to introduce which pipelines we have in each of the processes. So when we create a new feature, we will create a feature branch, and as we are providing changes, we are going to have automatic validation checks that are going to pass the first quality control in an automated way. At that moment, we also want to have some mechanism to manual testing, which is what we know as a Prestaging environment that Fábio is going to introduce later on. But basically, it's our way for us to test manually the specific changes in a remote environment. Whenever that is done, we will merge it to development, we will create a release, and here in the release, we have also an environment that is called staging. This staging environment is a production-like environment when we are going to have all the changes integrated and manual tested by a quality assurance team, ensuring that is closed in an environment that is production-alike. We will merge it back to master and we will deploy to production. I have not said it, but at some point, we will have in any of the stages of these code changes, the validation checks. We are continuously ensuring that no change is going to be introduced that are going to break. So automation is there also to help the quality. But now let's take a look into the validation checks that we have in our pipeline. So we know that the validation checks are going to enforce stability and reliability on our delivery of features. We are having this feedback on each PR and each commit. Whenever a developer creates a PR, we need all the checks to pass green for being merged, otherwise we don't enable it. This is a common pattern that is happening in all repositories, and you will already know about them. But now let's take a look into specific things that we are testing in our pipeline. The first one that we have is lint. Lint is our way to analyze the source code to try to find some errors. But above all, what lint is providing us is our way to keep our code clean and formatted, with some configuration rules that we have beforehand settled by the team. This is a fast process which allows us to pass it as a pre-commit hook. So any developer is going to provide changes, we will pass these changes the lint check. For those that don't know about this, they can look for these libraries to set them for their pipelines. The next one that I'm going to talk about is SonarQube. SonarQube is like an advanced version of lint. It's going to provide an advanced analysis and it's going to detect more kind of bugs or vulnerabilities, again, from a previous configured rules. SonarQube analysis is like it's going to provide automatic reviews. That means that on each PR, we are running this process, and if SonarQube detects that the code is in a bad state, it will complain in red, and the developer will be forced and notified to improve this to be green. Above all, SonarQube is a tool for us to also pursue the technical debt, because the kind of analysis that it can provide can detect when your code is not looking good. Some examples of the kind of analysis that it can have is that it can detect cognitive complexity on your code. So sometimes we have those functions that are like a spaghetti code where we are creating a lot of conditional branches. Like here we have like 20 ifs in a function. So this is detecting it and is saying, okay, developer fix it because this is not readable and it's not going to be maintainable. So this is a good way. But this happens not only for new code, it's also happening on existing code. So if you have the luck to touch some code that is ugly, you will have also the luckiest person to fix it and clean it. It can also detect code duplication, type errors, secret leaks, and much more. I really recommend that you check out this tool because it's really amazing for having quality on your code. Now let's talk about our mechanism in the CI pipeline to validate the functionality of the code. The unit check is allowing us to test pure functions and components. With pure, I mean those functions that its execution is not creating any side effect. It doesn't have any communication with an external source or a global state. For that, we use Jest library and other tooling like Mocha, Che, and etc. This is a really fast process because the nature of the things that we are testing is pure logic. We have then integration checks. What happens when you want to test functionality that is attached to Meteor infrastructure like Meteor methods, subscriptions, or even collections? We use this integration test. In contrary with unit testing, integration tests will test functionality that relies on external sources like Mongo database through the Mongo collections. So here we are also maintaining a test data set, and we are also, for the nature of kind of test that it is a slow process. One of the things that we need to ensure in a continuous integration pipeline is to have the green response faster as possible. And this is a slow process. You need to think about a strategy to improve the parallelization. And for doing that, for instance, in our case, we are creating our specs taking into account the app they belong or the package, creating shared codes and modules. For that, we use the mechanism of Meteor testing Mocha, the built-in mechanism for tests in Meteor. But then let's talk about what is our main start of our CI pipeline, that is end-to-end. I'm going to show you here an example of what it is for you to understand how powerful this is. Okay. Yeah, at the end with this end-to-end test, what we are doing is that we are going to test the logic of the things that are going to use the final user. At the end, we are automating actions against a browser of all our system in our apps. In this case, that I'm showing as an example, we are testing the session system in our apps. We are passing, ensuring that magic link works, email and password, also forgot password, and every use case around the session system. This is also requiring, of course, to maintain our own test data set, because at the end here you are bundling your Meteor apps, you are starting them, you are having also Mongo on, and you have this complex kind of process that needs to be run. This is a slow process, of course, and the way it's more slower as you are adding more specs and specs. At some point, you need also to think about a parallelization strategy for it. And in our case, it has been to encapsulate in isolation the process to build the apps, to start them, and to pass group of specs only, not all the specs. And here you can see that we are creating a lot of groups of different specs per application and try to test them here. We are using Cypress technology for this. As this is the kind of test that is providing more joy for us, but also more headache, I have to say, and frustrations, a lot of them, I want to talk about the pros and cons of this. The most important advantage, I think, is clear. You can identify regressions caused by any change, even core changes, in any part of your system that has the coverage. And in the development phase, not before releasing, not just in production. Apart from that, EndtoEnd encourages you to describe the system and automate any use case that you have. At the end, this is producing like a guide for all the functionality that you can get in your app. And this can be consulted by any people by any time for understanding more about your applications flow. But the cons is also something I consider. EndtoEnd needs a complex infrastructure that can support this kind of high resource demanding processes. To apply properly the parallelization, you need, as I said, to isolate it and repeat the process to build the apps, which mean more resources, which mean also more money costs. You also need a bunch of specialists that can automate using Cypress. You need like a kind of profile that is like a developer that can maintain those specs, because at the end you are programming in JavaScript and you have to have this grasp of development. But at the end, you also need to have a grasp on how to create test cases that are a reflect of what the final user is going to test. Normally, tests should not be created by their own developers or the people that is implementing. So you need to have like a profile that is in the middle of it, which sometimes is hard. Another problem of EndtoEnd is that it introduces flagginess. What is flagginess? Flagginess is when your test fails randomly. You have maybe some deterministic use case that should always be green following those stages, but is going red. That can be produced for several things. So you need, again, some specialists that can detect all this. Can come from the infrastructure. Maybe you are allocating less resources than the process needs. You need to take into consideration that. The flagginess can also be introduced in the way you describe Cypress and the tests. So again, you need to, and it's well known by the community that Cypress has these problems. So you need to put solutions there. It's challenging sometimes. And you also, maybe is the app that you have implemented, your use cases are randomly working in a way that is not expected. You need to solve these things as well. But yeah, we have presented all kinds of tests that we are using in our CI pipelines. But we are not just, we need to know why we need to do tests or which kind of coverage we need. And for that, we have other check, which is the test coverage, which is going to allow us to track the percentage of the source code that is reached by tests. We are supporting this for all kinds of tests that we have, for unit integration and end-to-end. At the end, we are analyzing our code to know how many flows are reaching, test flows are reaching that code. And we are merging the results for any of these kind of tests and getting a number. Here, for instance, is a use case that should not happen. For instance, we have the release, this one release on a branch that has introduced 2.3K of new lines. And these new lines are only 49% of coverage. What will happen that if we don't have 100%, then after merge, our global number is going to decrease. So this is something to pay attention. But I want to talk a little more about the pros and cons. So the advantages are clear. This number is going to give us that we need actually to write more tests, because more tests at the end, 100% of tests is going to mean that you won't need to do a lot of manual testing. So you have coverage for everything from your app. We are 50% or something like that. So we need a lot of manual testing as well. But with this, we know that we need to. But when or where we need to, this is the other question that we are also going to get an answer. And this tool provides us each line of our code base and if it is reached or not by the tests. But the cons, again, it has a complex infrastructure behind the scene, and also the initial setup, these things about the different, how to get the different coverage for any kind of test, to merge it, and to run the apps with Istanbul that you need to, this is a really slow process. At the end, it's a mess. We have created in a separate repository an approach that can work, and we are thinking that we are going to provide to the community because they will be able to apply the same things that we're applying here, but it is not ready yet. So if anyone is interested, we can share it to you. But again, this is providing for us that we need to put a lot of resources, and this is a lot of money as well. We need to think in strategies to save money on this kind of side pipelines that we use. But the last one is art. Art is the way that we have to get insights on each change that we are going to provide in terms of how the app bundle, JavaScript, CSS size is going to be. And also the initial load time and Meteor subscription time and documents. At the end, this is working thanks to Puppeteer. Puppeteer, we are recording some actions, automatic actions that Puppeteer runs in a browser, headless browser. And a CDP session, what it's going to do is to connect to the dev tooling and get the metrics that we have set here. Then we are going to pass these metrics to Elasticsearch, and we will have a graph that we could see if we are improving or not as we provide new features, new changes, new releases. So this is a really important thing for us to understand, that we are going to deliver quality and improving it incrementally. And the next thing is to talk about the Prestaging that I have mentioned it before. And for that, Fábio is going to give more details about it.
Hi, everyone. Just want to add that I'm the guy that gets really happy when I can automate things for developers and quality assurance members here in Pathable. That makes me very happy. And now talking a little bit about our pre-staging environments. We have pre-staging environments here that the developers or QA members can create. They can create this to run manual tests over pull request changes. For each pull request, they can create an entire environment with all our apps running. We have 5 apps running and the MongoDB running together with it, and they can validate. They can use it to do some validations of the changes and demos of work in progress for features that is in progress. And why we need it? Nacho showed us that we have a lot of automated tests like end-to-end and integration, but we need these manual tests because we don't have 100% of our code coverage by these tools. Then we still need this kind of environment for the developers and QA use to validate their changes. And please, next, Nacho. And here is a screenshot of a real pre-staging environment running with running over the internet with SLCS certificates, the HTTPS, and with domains for each of the apps that we need to access. And that's it here, just it. I will talk later about these certificates and the DNS records generation. And here we created a Meteor application from scratch we called it CI dashboard, and developers and QA members can use it to manage the GitHub pull requests to see a lot of details. We integrated it with our tools, with GitHub and Target Process and Kubernetes and Jenkins via APIs. This application integrates with these other tools. Can you pass it? That's it. Here we have the screenshot for this application that we built here. We have all the open pull requests on the left, and we have a bunch of features here, like you have links for the GitHub pull requests. You can group the pull request by team, author, status, or base branch. That's master or development, or another feature branch in our case. And we have these Prestaging controls where the developer or QA could deploy, redeploy, restore database, stop and start the Prestaging, and extend the time for it to be turned on, because when you deploy a new Prestaging, we set 4 hours time for it to turn off automatically without anyone has to turn off it and not forget to turn it off. And here we have the peer checks that Nacho explained before, the art, the end-to-end, the integration, lint, Sonar, and unit, with links for the Jenkins job builds that generated this status here. And we have even more here, because we parsed the logs for these Jenkins builds and provide for the user on this failed link. We provide the end-to-end errors and some others checks errors here. We have it. And here we just have a link for target process user history or bug that is linked to this PR. That's it. And now I'm talking about Docker a little bit. Docker is an open platform for you to develop, ship, and run your application. It allows you to separate your applications from your infrastructure. Then you can have your infrastructure isolated. You can build an image and have all the dependencies that you need to run your application inside the Docker image, for example. And from this Docker image, we can create containers to run any commands or process or application servers from it. It's a thing that we do here. And if you don't know about anything about Docker, a Docker can be simplified or as one or more running operating system process on a machine. But that's it. And now I'll talk about our Docker Pathable image. We created here a concept that we have a Docker image, only one, because it's easier to maintain. Then we install everything inside this image, like the Meteor dependencies, even the repository is checked out inside this image to be fast when we need to run something that depends on the repository. And it contains all the scripts inside the repository that is checked out on the image. It contains all the scripts that you need, shell scripts, to run all our process, like integration, end-to-end, lint, and others, art. And with it, we can have a really fast replication of our environment. Here's an example, a piece of our Docker file that builds our Docker image, just a piece for you to see, just a little bit of it. And on the right, you have 2 images that we use, one for the master branch and one for the development branch, because it could have different dependencies. Like in master, I could use Meteor 2.3, and in development, I can have Meteor 2.4, for example. Then we need these different images here. Next. And now I'm going to talk about a little bit about the Kubernetes that we use here. Kubernetes is a tool to work straight Docker containers. It's a very, very powerful tool that I'm working with it since like 3 years ago. And I like it a lot. It solves a lot of problems. With it, we can scale nodes that in the end is EC2 instances. On our case, is virtual machines on a cloud. We can scale it virtually infinity, because you can have as much as nodes as you want to run your process on top of it. And talking about the concept, real basic concepts, because Kubernetes is huge, but it's a node is a virtual machine, as I said, where the pods run. And a pod is one or more Docker containers running on a node. It's a group of containers. In our case, we are using only one container per pod, the most of times, and that's it. Here I'm going to talk a little bit about Coops. I don't know if you know about Coops, but Coops is a very nice tool that you could use to provision your cluster, to provision your Kubernetes cluster, and its instance groups. What is an instance group? An instance group, it's a group of nodes that you select some size and some disk for it. On AWS, you can see here the groups. And Coops is very nice because you can create several clusters with the same configuration, for example, in a very automated way. Like you have here the two clusters. We have the sandbox and we have the staging, that is our main cluster. And then you can replicate Kubernetes environments with Coops using this tool. And another detail here is that we use a custom AMI, AWS AMI, that is a EC2 image. It's a machine, it's an image from a machine that has our Docker image downloaded inside it, because it will be faster when Kubernetes creates a node. It creates the node using this AMI, and the Docker image will be already downloaded on it to be faster to instantiate the pods later. And we chose Jenkins as our CI tool here, mainly because Jenkins is a very nice tool. You can extend it a lot because it has millions of plugins. I don't know. And we use Jenkins job DSL to generate our Jenkins jobs and maintain it as code. That is very nice, because every time we want to change it, it's on the code. We change the code and the jobs are generated again. It's very nice. And it's a very flexible tool, as I said. You can use Groovy scripted pipeline code. That is basically Groovy scripts that uses Jenkins methods, and you can customize your way. And the possibility to run Jenkins itself on top of Kubernetes. Then we run Jenkins on Kubernetes too. That's a very nice thing, because Jenkins can communicate very easily with Kubernetes because it's running on top of Kubernetes. That's very nice, and it's possible to create pods to run our jobs too, using this Jenkins Kubernetes plugin. And then when you have a Jenkins job, you could use this plugin to run your jobs inside on top of a Kubernetes pod. That's very nice because it scales as you want. That's it. And here we have an overview of our CI infrastructure. We have the Kubernetes in the middle here because it's the center. And we provision it with Coops, as I said before. And we have Terraform here too. We use Terraform. Terraform is just a language for you to describe your infrastructure and provision it. And you use it to have all our dependencies as code, like we install Jenkins, SonarQube, Cluster Autoscaler, External DNS, Cert Manager, Prometheus, Grafana, and other tools we install with Terraform because we can replicate it to install on other cluster like Sandbox or a production cluster if you want. And we use this tool, this very nice tool too. And here talking about Jenkins demands pods to Kubernetes that I said before. You can run your Jenkins jobs using pods on Kubernetes. That's very nice. And when you do it, Kubernetes asks, when you ask a pod for Kubernetes, if you check, if I had some node, an EC2 instance to run this pod, I will run onto it. If I don't have, this tool here, Cluster Autoscaler, will create a new node, no matter, it create a new node for you, and then it will run it will create the pod on this node and run your job on it. And it will be very fast because, as I said before, we have the Docker image already downloaded on these nodes. We use Amazon ECR here as our Docker registry, and we have it. Ready to go. Like when you create a new node, we have the image inside, and it will start to run automatically very fast. And that's it, I think here. And here we have an example with our end-to-end test. Nacho created here this very nice concept of test groups, and we have 38 test groups running in parallel here for every commit, on every pull request, and every commit on every main branch that is master and developer and development in our case. And you could imagine that has a cost, and the machine is growing because if you ask for a lot of pods, it will have to have a lot of nodes to run it, and it will ask to Kubernetes, and Kubernetes will create the nodes to run these pods, and it's a lot of pods. We are talking of 38 pods, like with memory, with more than 5 gigabytes of memory and 3 CPU each, and it will create the nodes that accommodate these pods to run, and then it will scale down the nodes. When Kubernetes sees that it don't need the nodes anymore, it scales down the nodes, and we stop paying for this. It's very elastic, this stuff, very nice. And here you can see the Kubernetes pods over time. You could see that we reach more than 1,000 pods in some moments, running at the same time in parallel. It's very nice to see this. And the next one, you see the nodes. You see the nodes coming and going. That's the magic of Kubernetes. Very nice tool. It control, and the cluster autoscaler too. That we installed this tool that's name is cluster autoscaler. We installed it inside Kubernetes to have this behavior here to go up and down with the nodes. Very nice. And I think that's it. I have for today. Yeah. Just one little thing I forgot. Can you go back, Nacho, please? Like in the CI overview. Yeah, this one. I would like to talk about these other tools, this external DNS and cert manager, because it's very interesting tools. The external DNS is a tool that you install in Kubernetes, and it creates for you automatically. It creates on your AWS Route 53 or other cloud provider. It creates the DNS records for you automatically based on your Kubernetes ingress. That is a concept that Kubernetes has. You can create an ingress there, and then this tool creates automatically for you the DNS records, and the cert manager that creates automatically for you the SSL certificates for you to have it very, very easily. That's it. Thanks, Nacho.
Okay, I think it's time for questions. I'm not sure if we have some of them. I think yes. So the first question is, how did you automate updating of release day branches? Is there a GitHub action or something like that? What about conflicts? Isn't this a step that needs a manual overview? Okay, in this case, yeah, no, we are not using GitHub Actions. Fábio has talked about what we are using for the CI infrastructure, the pipeline, which is Jenkins. And what is happening behind the scenes is that Jenkins is listening into changes on the Git repository, and any change that is pushed on any of the main branches is producing to trigger the automatic update of those other branches. If there is a conflict, we are alerting in our communication tools like Slack. But normally we are being optimistic about this. So we merge as soon as possible for avoiding conflicts later. If developers has the latest version, they will work straight with that stable version. So this is the thing we are pursuing. But if there is conflict, we warn about that, and then a manual procedure needs to happen for the developer involved. There is other question. How is to use Pathable as a speaker? What do you think, Fábio?
Could you repeat, please?
How is to use Pathable as a speaker? To use actually the platform that we are
using. It's very nice. It's a very good tool, I think. Very nice, but it has a lot of features. Nice.
Yeah, for me, it has been the first time using it actually, and I am in Pathable 6 years, something like that. So.
Yeah, for me, it's the first time too. I like it.
So there are other questions. This is really cool, guys. Congrats on this infrastructure. Can you measure the decrease in bugs and hot fixes after applying this process? Of course, in the touch management tool, we could see that impact, but I would say that this is something more on other team that is tracking this information down. What we are trying is to provide as much automation as possible to reach a situation that our releases are the more stable. And of course, that will be known at some point. I think lately we are doing quality releases, and EndtoEnd is helping a lot on it. But I don't have more information about that. I have not seen the graphics within the touch management tool to verify that it's having some impact in comparison with before. I believe yes, but it's from another. What were some Meteor quirks that you had to account for in the CI. I mean, in our CI, some of the things that we have been facing is to bundle the Meteor apps there. I'm not sure if this question, this answer is the correct one, but of course we are integrating our CI pipeline, the Meteor processes. And I think one of the challenges has been to create this single image that we have with all our processes, Meteor runs as well, how to build the Meteor applications and integrate it in our CI for using our tools. I'm not sure if you have any other feedback, Fábio, around these topics.
No, I think that's it.
Another one is, can you share your worst experience among all of these complex moving parts? An instance where everything went down all at once or something like that, assuming that happened at least once. We have an icon, a characteristic icon in our team that is like a bot in fire. So you can imagine. We have faced a lot of problems. We will say that we are in a safe spot because almost all our pipeline is for development time. It's not affecting to production. For production, we are relying on Galaxy, and Galaxy has provided us the stability that we have found. And then all the CI is just for development, which usually is not some urgent thing.
Yeah, but we had some cases when CI checks started to fail a lot for everyone, and we decided to implement a strategy that we retry it if it fails. If it fails, we retry it at least 3 times, and it helped a lot because sometimes an instance could die, like a EC2 instance could die for some reason, or if you are running into on spot instance that costs much less than their regular EC2 instance, AWS could terminate it, and it will crash your process. And these retries are helping us a lot because it only retries, asks for a new pod, and it runs again. That's it.
Yeah, that is all. Yeah, we don't have any more questions. So I think this is it. Thank you, everyone. It has been great to have first experience presenting in Meteor Impact, but also in Pathable, actually. And let's see you in the next talk that I think is around deployment to Galaxy that is easier, right, Felipe? Bye-bye, see you.
Thank you, everyone. Bye-bye. See you next time.